Hello there, and welcome to the Sleepiest Science Facts. I'm so glad you found your way here. In this peaceful space, we'll slowly drift into a quiet world of weather facts about the gentle, slow-moving forces that shape the world around us. Each fact will guide us further into the vastness of time, the subtle movements of air and water, and the calm unfolding of nature's rhythms. As you relax into this, let your body settle. Let your thoughts flow gently, and let the slow, rhythmic patterns of the world's weather patterns calm your mind. If this peaceful journey helps you unwind, consider liking and subscribing to the channel, but only if you feel it is right for you. For now, let's take a quiet, slow, and gentle step into a world of weather. The winds are a constant force, quietly shaping the landscape. It is easy to think of wind as something simple, something that moves the branches and trees, rustles the leaves, and brushes past our skin. But the wind moves with a vastness that dwarfs all human measure. Its presence is invisible, but always felt, wrapping itself around the contours of the earth. Sweeping across oceans and mountain ranges with quiet power, the wind moves so slowly, patiently, without hurry. It is as though it has all the time in the world, and yet it is never still. Even when we sleep, the wind continues, traveling silently across the world. The wind is a traveler that never rests. It moves from the poles to the equator and back, from one place to another, in slow, subtle shifts. It is as though the wind is constantly weaving a quiet tapestry of motion over the oceans, through the valleys, and across the plains. As it moves, it interacts with the world around it. It touches everything, and yet it leaves no mark. The wind is a presence that is always there, invisible, yet ever so tangible. The slowness of its motion reminds us of the steady passage of time. It does not rush. It does not hurry. It simply moves, quietly, steadily, through the vastness of the earth. Clouds are the gentle whispers of the atmosphere, shifting and drifting. Clouds seem to float effortlessly in the sky, as if they are simply a dream, drifting on a wind we cannot see. But clouds are more than just ephemeral shapes. They are the product of moisture that has been slowly gathered from the Earth's surface, lifted into the air, and transformed by temperature and pressure into visible forms. The process is slow, almost imperceptible. First, moisture rises from the oceans, lakes, and rivers as tiny droplets of water that cling to particles of dust in the air. Slowly, these droplets begin to gather together, forming larger and larger clusters. Over time, the tiny water droplets merge, grow heavy, and form clouds that appear to float in the sky with effortless grace. As we look at the clouds, it is easy to forget the incredible patience that went into their formation. It is not a chaotic, rushed process, but a gradual unfolding. The clouds are not static. They are constantly changing, constantly shifting, moving across the sky in slow, deliberate patterns. Watching a cloud drift by can remind us of the slow passage of time. It moves with an elegance that suggests that the world is always in a state of quiet change. Even when we cannot see it, rain is a gentle return to the earth, like a quiet reunion. Rain is often seen as something sudden or dramatic, storms that appear out of nowhere, sending droplets tumbling down in torrents. But in truth, the process that brings rain to the earth is one of gradual, slow accumulation. It begins as the moisture in clouds condenses and grows heavy. It gathers, and as it does, the air cools, and the water finally falls from the sky. Rain does not fall in haste. It moves in gentle drops, each one carrying with it a small fragment of the sky. As it lands on the earth, it nourishes the ground, replenishing the rivers and lakes, feeding the plants and trees. The rain does not ask for attention, nor does it demand to be seen. It falls quietly, slowly, bringing life back to the earth in a slow, unhurried way. There is a rhythm to the rain. Each drop falls in its own time, but as they fall together, they form a quiet symphony. The soft sound of rain tapping against windows, the hush of rain on leaves, all speak of the world moving slowly, steadily, and calmly. It reminds us that we too can find peace in the slow rhythms of nature. The ocean's waves move in a pattern of eternal repetition. The ocean, vast and endless, is a body of water that moves slowly and methodically, Its waves rise and fall like the breath of the earth itself. They move in a pattern of eternal repetition, pushing against the shore with the same unhurried rhythm, time after time. Each wave is born from the slow movement of the wind across the surface of the water. It travels across vast distances, moving with a calm determination that speaks of the ancient forces at work in the world. The waves do not rush. They rise and fall in their own time, with patience that stretches across millennia. They are a reminder of the vastness of the Earth's oceans and the slow, patient dance of the planet's natural forces dot as we watch the waves. We are reminded of the slowness of time itself. Each wave is part of a pattern that has been unfolding for eons. The ocean's waves move not in haste, but in a rhythm that is as old as the earth itself. And as we listen to the sound of the waves, we can feel the calm and steady pulse of the planet beneath us. The sun's warmth reaches us after a journey of millions of miles. When we feel the warmth of the sun on our skin, it is easy to forget the incredible distance it has traveled to reach us. The light that warms us has taken millions of years to travel from the sun, crossing vast stretches of empty space before it finally touches the earth. This light moves at the speed of 186,000 to 182 miles per second. Yet even at this incredible speed, it still takes time to reach us. The sun's warmth is not instantaneous. It is a patient, gradual force traveling across the expanse of space, arriving at the earth as a slow, steady stream of energy. And once it arrives, it gently warms the earth, creating the conditions that support life. As we bask in the warmth of the sun, we can reflect on the incredible journey that this light has taken. It reminds us of the vastness of the universe and the patience required for light to travel across such enormous distances. The warmth we feel is not something that happens suddenly. It is the culmination of a slow, steady process that stretches across time and space. The seasons shift with a quiet, almost imperceptible rhythm. The seasons come and go, one fading into the next, yet there is no rush, no sudden change. The transition from one season to another happens slowly, almost imperceptibly, like the turning of a page in an ancient book. The earth moves through its orbit around the sun with a quiet patience, and as it does, the tilt of the earth's axis gradually shifts the balance of sunlight across the globe. Each season is a reflection of time's passage: spring's fresh blooms, summer's heat, autumn's golden hues, and winter's stillness. Each one follows the other in a perfect cycle that has been unfolding for millions of years. The subtlety of this cycle is what gives it its beauty. The changing of the seasons is not dramatic or sudden. It is a slow and steady unfolding of nature's rhythm. The earth does not hurry, and neither do the seasons. They change with grace, with a patience that speaks of the steady, unhurried movement of time itself. As we move through the seasons, we do experience this slow change. We witness the subtle shifts in temperature, the gradual lengthening or shortening of days, the slow blooming of flowers, and the eventual fall of leaves. Just as the seasons pass quietly from one to the next, we too move through our own cycles, growing and changing in ways we may not always notice, but which are always there, unfolding at their own pace. The temperature of the atmosphere varies with such subtlety, it is barely noticeable. Temperature changes in the atmosphere are often so gradual, so slight, that they go unnoticed by most of us. The air we breathe, the temperature of the world around us, shifts ever so slowly, day by day. The mercury rises and falls in a quiet dance as the sun's rays warm the earth and the cooling night air restores balance. Even during the hottest days of summer or the coldest moments of winter, temperature changes do not happen suddenly. It is a gradual process, one that unfolds in tiny increments that we may not consciously perceive. The atmosphere moves with such subtlety, such quiet precision, that even though we feel the effects of temperature, we are rarely aware of the slow, steady adjustments happening just above us. This gentle change in temperature is a reminder of the world's vastness. The atmosphere stretches above us like an invisible blanket, constantly shifting, never still. But it does so at its own pace, with a slowness that mirrors the gentle passage of time. The subtlety of temperature change invites us to pause, to take notice of how slowly the world moves, Even when it seems like everything is changing around us, air pressure is a silent force, ever present but seldom noticed. Air pressure is another invisible force that shapes our world, though it is rarely something we consider in our daily lives. Yet, air pressure is always with us, shaping the flow of wind, the formation of clouds, and the way weather systems move across the globe. The atmosphere is composed of countless particles, constantly in motion, and the weight of these particles pressing down on the Earth's surface creates air pressure. This pressure fluctuates slowly over time, rising and falling with the weather, shifting as high and low pressure systems move across the sky. Air pressure is part of a slow and constant rhythm, like the tide of an unseen ocean, pressing against us in ways we cannot see but can always feel. When air pressure changes dramatically, we may feel it in the form of headaches or shifts in weather, but even the smallest variations go unnoticed. Air pressure moves in a calm, unhurried dance, slowly building and releasing energy as it shifts across the Earth's surface. Just as the wind whispers to us from a distance, air pressure speaks in the same quiet language always present, but never demanding attention. The Earth's rotation is the underlying rhythm of all weather patterns. The rotation of the Earth, though it may seem a constant and unchanging force, is an underlying rhythm that governs the movement of the atmosphere and, by extension, all weather patterns. As the Earth spins on its axis, the distribution of sunlight shifts, creating the patterns of day and night and setting into motion the flow of air, water, and heat around the globe. This rotation is slow and steady, turning the world with a patient, measured rhythm. It is not something we feel directly, but it is the fundamental force that drives the circulation of the atmosphere, the ocean currents, and the patterns of weather that we experience. The Earth's rotation is like the ticking of a clock, not something we notice consciously, but always there, marking time and ensuring the flow of life continues. The slow turn of the Earth means that the weather does not happen in a single moment, but is part of a larger, ongoing cycle. Weather patterns form and dissipate over hours, days, and weeks, driven by the quiet, rhythmic rotation of the Earth itself. It reminds us that time moves slowly, and weather is not something that happens suddenly, but is part of an ongoing process that has been in motion for eons. Humidity is a delicate balance, constantly shifting like a soft breath in the air. Humidity, the amount of moisture in the air, is another subtle, ever-changing aspect of weather that often goes unnoticed. The air around us holds water vapor in varying amounts, depending on the temperature, pressure, and other conditions. This moisture is invisible to the naked eye, but it plays a quiet role in the weather, influencing everything from cloud formation to precipitation. Humidity shifts constantly, ebbing and flowing like the tide of the air. It is a delicate balance, one that changes slowly, almost imperceptibly. When the air is humid, we may feel it in the stickiness on our skin, but even then, the change is gradual, building over time. Similarly, when the air is dry, it is not a sudden, sharp dryness, but a slow, steady process that dries out the land, the plants, and the air. As with so many elements of weather, humidity is part of a larger cycle, a slow and unhurried process of evaporation, condensation, and precipitation. It moves like a soft breath, inhaling and exhaling with the rhythm of the Earth, never rushing, always shifting in quiet harmony. The water cycle is a continuous loop of transformation. Water, in all its forms, liquid, solid, and gas, moves through a continuous cycle that is essential to the planet's climate and weather systems. The water cycle, or hydrological cycle, is a slow, unbroken loop that moves water from the surface of the Earth into the atmosphere and back again. Like an endless dance between the land, sea, and sky, water evaporates from the oceans and lakes, rising into the air as water vapor, where it cools and condenses to form clouds. These clouds move across the sky, and when they become heavy with moisture, they release rain, snow, or hail back to the Earth. Once on the ground, the water flows into rivers and streams, eventually returning to the oceans, only to be lifted up again in a never-ending cycle. This process unfolds slowly, over time, each stage blending seamlessly into the next. The water cycle is a reminder of the quiet, persistent rhythms that govern the earth. It is not a process that happens suddenly. Rather, it is a slow, patient transformation that takes place in the background, shaping the world around us without fanfare or haste. Just as the water moves through its cycle, so to do the seasons, the winds, and the patterns of weather, always moving, always changing, but in their own time, in their own quiet, patient way. The atmosphere is a thin layer, but it holds the entire world's weather. The atmosphere, the thin layer of gases surrounding the earth, is a delicate yet powerful entity. Though it may seem insubstantial, it is the very foundation of all weather patterns. It contains the oxygen we breathe, the nitrogen that makes up most of its volume, and other trace gases that contribute to life and the movement of weather. The atmosphere extends only about 60 miles above the Earth's surface, yet within this narrow band, it holds all the conditions necessary to create weather. The air is constantly moving within this layer, influenced by temperature changes, pressure systems, and the Earth's rotation. These movements, though they might seem small on a day-to-day basis, are part of a larger system of atmospheric circulation. Winds shift, moisture rises, clouds form, and rain falls, each part of the larger mechanism unfolding in its own time. The atmosphere's movement is imperceptible on a moment-to-moment basis, but over time, it creates the weather patterns that define our world. This thin, invisible layer is a reminder of how vast and complex even the simplest forces of nature are. While it may seem fragile, the atmosphere is a robust, unyielding part of the earth, holding and shaping all the weather we experience. Thunderstorms are a powerful, yet slow-moving process. Thunderstorms are often viewed as dramatic displays of nature's power, but they unfold slowly, methodically, and patiently over time. A thunderstorm begins as warm, moist air rises into the atmosphere. As the air cools, water vapor condenses into clouds, and the cloud particles grow larger and heavier, eventually producing lightning and thunder. The creation of a thunderstorm is a slow, intricate process. It begins far before the first rumble of thunder is heard. Warm air slowly rises, and over time, the rising moisture and temperature create instability in the atmosphere. As this process unfolds, the cloud particles become charged, and when these charges meet, they create the lightning that we see flashing in the sky. Thunderstorms are often short-lived, but their formation can take hours. The storm moves slowly across the sky, quietly gathering strength as it travels, until finally, the storm releases its energy in the form of rain and thunder. The quiet, patient buildup of a thunderstorm reflects the unhurried nature of many of the Earth's processes. Slow, deliberate, and full of quiet power, the jet stream is a fast-moving current of air. Though its effects are gradual, the jet stream is a high-altitude current of air that moves across the Earth, helping to influence weather patterns. Although it moves at speeds of up to 200 miles per hour, its effects on weather are gradual and often imperceptible. The jet stream moves in large, meandering waves, its high-speed winds carving paths for low and high-pressure systems, directing storms, and shaping weather patterns around the globe. The jet stream is a reminder that even fast-moving forces of nature are part of a slow, patient cycle. As the jet stream shifts, it does so over long periods of time, subtly influencing the weather patterns of entire regions. While the winds may be fast, the way they impact the weather is gradual shifting temperatures, influencing precipitation patterns and guiding the movement of storms. The jet stream's power is in its consistency, its slow but steady influence on the larger weather system. The Coriolis effect gently shifts the path of winds and currents. The Coriolis effect is a subtle, yet significant force that arises from the Earth's rotation. It causes moving air and water to curve to the right in the northern hemisphere and to the left in the southern hemisphere. This effect, while invisible, plays a fundamental role in shaping weather patterns and ocean currents. The Coriolis effect is a slow-moving force. It doesn't create sudden changes or dramatic shifts, but it shapes the movement of weather systems over time. As air moves across the Earth's surface, the Coriolis effect gently nudges it off its path, influencing everything from the formation of cyclones to the flow of ocean currents. It is a quiet force that shapes the world around us, slowly, almost imperceptibly, guiding the winds and waters in their eternal dance. A calm day in winter is the result of long, slow cooling. Winter is often associated with the sudden arrival of snowstorms and freezing temperatures, but many of the calm days in winter come after long periods of gradual cooling. As the days shorten and the sun sinks lower in the sky, the Earth's surface slowly loses heat. The air cools gradually, and eventually, the balance of temperature and pressure shifts, leading to the still, quiet days of winter dot on these calm days. The cold is not a sudden shock, but a slow and patient force that has been unfolding for weeks. The coolness in the air is a reflection of time passing as the earth cools ever so slowly, until the quiet stillness of winter settles in. These quiet days invite us to slow down and reflect, to appreciate the slowness of nature's rhythms and the peacefulness of the changing season. Fog forms slowly, a gentle reminder of the world's hidden complexity. Fog is a weather phenomenon that forms from tiny water droplets suspended in the air, often in the early morning or late evening when temperatures are cooler. The process that creates fog is slow, requiring a careful balance of temperature and moisture. It is not the result of a sudden event, but a gradual coming together of the elements in the atmosphere. As the temperature cools overnight, the air becomes saturated with moisture, and the moisture begins to condense into tiny droplets. These droplets cling together, creating a thick, silvery haze that reduces visibility and transforms the world around us. Fog is a reminder of the subtle processes that occur in the atmosphere, hidden from our immediate view. It is a quiet, slow-moving phenomenon that reflects the complex and unseen workings of the natural world. In its stillness, fog invites us to pause, to notice the complexity that exists just beneath the surface, waiting to be discovered. The moon's gravitational pull influences tides in a slow, steady rhythm. Tides, the regular rise and fall of the ocean surface, are driven by the gravitational pull of the moon. As the moon orbits the Earth, its gravity pulls at the oceans, causing the water to bulge slightly toward the moon. This force is not a sudden or violent one, but a gradual, slow effect that happens twice a day, creating the ebb and flow of the tides. The moon's influence on the tides is a reminder of the quiet, patient forces that shape the natural world. The tides move in a slow, rhythmic pattern, rising and falling with the same unhurried pace day after day. The moon's pull on the Earth is a constant, steady force, shaping the rhythm of the oceans with every turn. Just as the tides move with patience, so to do the other forces of nature slowly, steadily, in quiet harmony. Wind patterns shift with the changing of the seasons. Wind patterns, though seemingly random, follow slow, predictable rhythms as the seasons change. During the warmer months, winds tend to blow from the tropics toward the poles, and in the cooler months, the reverse happens. This shift, a gradual, a persistent one, is influenced by the difference in temperatures between the land and the sea, as well as the Earth's rotation. Each shift in wind patterns reflects the slow movement of time itself. As the seasons change, the winds adjust accordingly, not in sudden bursts, but over the course of days and weeks. It's as if the winds themselves are taking their time, drifting from one place to another as the Earth's temperature and pressure systems gradually alter. As we observe these slow shifts, we can't help but notice the quiet, rhythmic way the world around us changes, mirroring the subtle changes in our own lives. This constant, slow-moving process is both calming and grounding, reminding us of the great forces at play on our planet, forces that are always in motion, yet always moving at their own patient, unhurried pace. The water in the oceans is constantly moving like a gentle, unseen current. The water in the oceans moves slowly, quietly, but continuously. Ocean currents travel across vast distances, their motions barely noticeable to the naked eye. These currents are driven by wind patterns, the Earth's rotation, and differences in water temperature and salinity. Over the course of time, these slow-moving currents shape the climate of the Earth, distributing heat from the equator to the poles and regulating global temperatures. What is fascinating about ocean currents is their invisible nature. Though we don't see them directly, their presence is felt everywhere. The gentle pull of a current, the way it shifts the waters along coasts, the way it brings warm water to cold regions and cool water to warmer ones, is a slow, constant process. The ocean's currents are a reminder that even in the most vast and seemingly unchanging parts of the earth, there is motion. It is a motion that is patient and purposeful, moving in its own time, at its own pace. The temperature of ocean water can change over long periods, slowly shifting the climate. The temperature of the ocean is a long-term variable that plays a significant role in the climate of the planet. While we may think of oceans as being fairly stable in temperature, the reality is that over long periods, ocean temperatures can change slowly, and these changes have profound effects on weather patterns and climate. As ocean temperatures shift, they influence the flow of air above the surface. Warmer ocean temperatures can lead to more evaporation, which in turn leads to more moisture in the atmosphere. This moisture fuels storms, clouds, and other weather phenomena. When the ocean cools, the reverse happens. Less moisture is released into the atmosphere, and weather patterns shift once again. These slow changes are often imperceptible in the moment, but over time, they shape our global climate. The ocean is a slow-moving engine of the Earth's climate system, one that moves at its own rhythm, neither hurrying nor rushing, but simply following the course set by the sun, the wind, and the planet's movements. The Arctic and Antarctic regions are vital to the global weather system. The poles of the Earth, though remote and seemingly isolated from the rest of the world, play a crucial role in the planet's weather systems. The Arctic and Antarctic regions, with their vast ice sheets, reflect a significant amount of the sun's energy, helping to regulate global temperatures. In these cold regions, the slow accumulation of snow and ice forms over millennia, contributing to the Earth's long-term climate stability. The slow melting and refreezing of ice at the poles is part of a delicate balance, one that maintains the steady rhythm of the global climate system. When ice melts, it affects sea levels, ocean temperatures, and weather patterns, creating gradual changes that ripple across the planet. The Arctic and Antarctic, with their immense and patient forces, are integral parts of the Earth's slow-moving weather system. These frozen regions remind us of the long-term processes that shape the Earth, processes that unfold over the course of centuries and millennia, moving at a pace we cannot always see, but which constantly impacts the climate. The Earth's tilt causes the length of days and nights to change gradually. The Earth's axial tilt is responsible for the change in the length of days and nights as we move through the seasons. During the summer months, the northern hemisphere tilts toward the sun, creating longer days and shorter nights. In the winter, the northern hemisphere tilts away from the sun, creating shorter days and longer nights. This slow shift in the length of days and nights happens over the course of months, and though it may feel sudden in the moment, it is in reality a gradual process, unfolding slowly over time. The tilt of the Earth is a constant, unchanging force, one that drives the rhythm of the seasons and the slow change in the day-night cycle. This slow, patient shift is a reminder of the larger, unhurried movements of the Earth itself. It speaks to the passage of time and the slow, steady nature of the world around us, a movement that continues without haste or interruption. As we experience the shifting lengths of day and night, we can find peace in the knowledge that these changes are part of a grand, slow-moving cycle that has been happening for millions of years and will continue for millions more. The Earth's magnetic field affects weather in subtle ways. The Earth's magnetic field, though invisible, plays a role in the weather systems around the planet. The field helps protect the Earth from solar radiation and cosmic rays, which can influence atmospheric conditions. The magnetic field's gentle influence on the atmosphere creates a stable environment for weather patterns to form. While the magnetic field itself doesn't directly cause weather, it interacts with the charged particles in the atmosphere, affecting the ionosphere and the way energy is transferred within the Earth's atmosphere. The interaction between the magnetic field and the atmosphere is a slow, subtle process, one that shapes the weather in quiet and imperceptible ways. It is a reminder of the invisible forces at work in our world, forces that, though they cannot be seen, are always present, quietly influencing the environment around us. Mountains can alter the course of weather systems. Mountains, those ancient, slow-formed structures, influence weather systems in ways that are not immediately apparent. As air moves across the landscape, mountains act as barriers, redirecting wind patterns and moisture flow. As air rises over mountains, it cools and condenses, often resulting in precipitation on one side, while the other side remains dry. This process, though seemingly sudden when we see the weather change, is actually a slow and continuous one. Mountains have been forming and reshaping for millions of years, and their influence on weather is both gradual and ongoing. The wind and moisture that move over them shift slowly, impacting weather patterns over vast regions, guiding the flow of air, and creating rain shadows and other weather phenomena. The interaction between mountains and weather is a quiet, constant process, one that reminds us of the long-lasting influence of the Earth's landscape and the way the land itself shapes the world's climate. The Earth's atmosphere is a constantly changing mixture of gases. The composition of the Earth's atmosphere, though seemingly stable, is constantly shifting. Air is made up of various gases, chiefly nitrogen and oxygen, but also carbon dioxide, water vapor, and trace gases that fluctuate over time. These changes in atmospheric composition are often gradual, driven by natural processes like volcanic activity, the movement of ocean currents, and the steady exchange between the land, sea, and sky. The levels of water vapor in the atmosphere, for example, change with the seasons, affecting humidity and precipitation patterns. Carbon dioxide levels rise and fall in response to natural processes like the growth of plants and the decay of organic matter. These shifts are part of the Earth's slow, ongoing process of balancing its environment. As the atmosphere changes, so does the weather, with subtle shifts in temperature, pressure, and moisture. It is a quiet reminder that the air we breathe is a dynamic, living part of the planet, a force that moves and changes slowly over time, affecting every weather pattern we experience. Sunspots and solar activity can influence Earth's climate very slowly. The sun, the source of all our warmth and energy, operates in cycles that stretch across decades. One aspect of this is the activity of sunspots, areas on the sun's surface that are cooler and more magnetic than the surrounding areas. These sunspots follow an approximately 11-year cycle with periods of high and low activity. While these cycles are gradual, the increase in solar activity can influence the Earth's weather in subtle ways. During periods of heightened solar activity, the sun emits more radiation, which can slightly affect the Earth's climate. This could lead to small changes in global temperatures or atmospheric patterns, though these changes are often gradual and not immediately noticeable. The slow, steady cycle of the sun's activity reminds us of the rhythms of the universe, unfolding at their own pace, far beyond human influence. It is a slow and subtle force, a reminder that the weather is shaped by forces that extend far beyond our atmosphere. Even the smallest changes in the sun can ripple across space and time, influencing the climate in ways that we feel over years and centuries. Ocean temperatures influence the global climate through El Niño and La Niña. The Pacific Ocean surface temperature shifts manifested through phenomena like El Niño and La Niña play a significant role in shaping the Earth's climate. These slow, cyclical events have global impacts on weather systems, influencing everything from rainfall patterns to the intensity of storms. During an El Niño event, the ocean waters warm, disrupting normal wind patterns and leading to warmer, wetter conditions in some areas and drier, cooler conditions in others. La Niña, on the other hand, is marked by cooler than normal ocean temperatures, resulting in opposite weather patterns. These events can last for months, unfolding slowly with far-reaching effects on global weather. El Niño and La Niña are powerful, yet they emerge from gradual changes in ocean temperatures and currents. They are part of a larger rhythm of the planet, with cycles that are repeated over time, reminding us of the complex, slow-moving interactions between the oceans, the atmosphere, and the weather systems that govern our world. The Earth's tilt also affects the intensity of seasons. The Earth's axial tilt is not just responsible for the changing length of days and nights. It also plays a significant role in determining the intensity of the seasons. When the Earth is tilted toward the sun, the intensity of sunlight is greater, leading to the warmth of summer. Conversely, when the Earth is tilted away, sunlight is less direct and winter sets in, bringing cooler temperatures. These changes, while seemingly dramatic in the moment, are part of a slow, cyclical process that unfolds over the course of the year. The tilt itself is a steady, unchanging factor, and the seasons, though marked by distinct differences in temperature, are part of a quiet rhythm that has been unfolding for millions of years. The gradual shift in the intensity of sunlight reminds us that the world is always moving, always changing, but at a pace that allows us to slowly adapt and find comfort in its cycles. Volcanic eruptions release gases that can cool the planet. Volcanic eruptions, though rare, have a significant, though slow, effect on the Earth's weather. When a volcano erupts, it releases gases like sulfur dioxide and ash into the atmosphere, where they can linger for months or even years. These particles and gases can block sunlight, leading to a gradual cooling of the Earth's surface, a phenomenon known as volcanic winter. While the cooling effect of volcanic eruptions is not immediate or long-lasting, in the grand scheme of the Earth's climate, it is a subtle reminder of the slow, sometimes invisible forces at play in shaping the planet's weather. The eruption itself may be swift, but the effects of the gases and ash in the atmosphere unfold slowly, changing weather patterns for months after the event. This process shows us that the weather is influenced not only by gradual changes in temperature and pressure, but also by events that happen far less frequently, yet still have profound, long-lasting impacts on the Earth's climate. The ocean's salinity plays a quiet role in the movement of currents. Salinity, the amount of salt in the ocean, may seem like an insignificant factor in the vastness of the oceans, but it plays a crucial role in the movement of ocean currents. Salt water is denser than fresh water, and this difference in density helps drive the movement of the ocean's deep currents, which in turn influence global climate. Changes in salinity occur over long periods of time, and these shifts can have subtle effects on weather patterns. For example, fresh water flowing from rivers or melting ice can reduce the salinity in certain areas, disrupting the normal flow of currents. Conversely, increased evaporation can increase salinity and strengthen currents. This slow, steady process of change within the ocean's waters is a reminder that even the smallest differences in the environment can have long-term effects on weather. Like the other forces shaping the weather, salinity moves with a quiet, imperceptible pace, gradually influencing the currents and the overall climate of the Earth. The Earth's landmass also influences weather by absorbing and releasing heat. The land plays an important role in shaping the weather, as it absorbs and releases heat in a way that the oceans do not. During the day, the land heats up quickly under the sun's rays, and at night, it cools down just as rapidly. This shift between day and night temperatures is a gradual process, as the land interacts with the atmosphere. In regions where the land heats up the most, like deserts or mountain ranges, this shift can lead to dramatic changes in weather patterns. But even in places with milder climates, the land's ability to absorb and release heat affects local wind and pressure systems. Over time, the land helps to balance the planet's overall temperature, smoothing out fluctuations and creating the conditions that support life. This slow, steady interaction between land and atmosphere is part of a larger, ongoing process. The land does not heat or cool suddenly, but rather at its own pace, influencing the weather in ways that unfold quietly, like the gradual change of the seasons. The Earth's weather is influenced by a balance of energy. The Earth's weather patterns are driven by an intricate balance of energy from the sun, and the ways that energy is absorbed, stored, and released by the Earth's surface and atmosphere. The process of heating and cooling occurs in slow cycles, where energy flows from the sun to the Earth, is absorbed by the land, oceans, and air, and then radiates back out into space. This balance of energy is not a constant, but it remains steady over long periods of time, creating the conditions for the weather we experience. The Earth's atmosphere is constantly adjusting to the influx of solar radiation, and while there are fluctuations from day to day, the larger processes happen at a much slower pace. The steady ebb and flow of energy from the sun shapes not only the temperature, but also the pressure systems, winds, and precipitation patterns that guide the Earth's climate. Understanding this balance of energy helps us see that weather is not the result of chaotic, unpredictable forces, but a slow and steady process, one that is deeply connected to the movement of energy across the planet. This energy flow is like the heartbeat of the Earth, slow and rhythmic, providing a stable framework for the unfolding of weather. The Earth's orbit contributes to long-term climate cycles. In addition to the axial tilt, the Earth's orbit around the Sun also influences the climate in gradual cycles. The Earth's orbit is not perfectly circular, but elliptical, and this shape causes variations in the Earth's distance from the Sun over thousands of years. These small shifts in the Earth's orbit, combined with the tilt, contribute to long-term cycles known as Milankovitch cycles, over tens of thousands to hundreds of thousands of years. These orbital shifts influence the Earth's climate, creating ice ages and warm periods. These cycles, while imperceptible to us in the short term, are vast, long-term processes that shape the very nature of our planet's weather and climate. The slow, cyclical nature of the Earth's orbit reminds us that change is not always sudden or dramatic. It unfolds slowly, in patterns that stretch across millennia. These slow cycles of climate change reflect the broader, more gradual changes of the Earth as it moves through space. The climate, like all things, moves at its own pace, governed by forces that operate on a scale far beyond human experience. Moving slowly and steadily through the vastness of time. Air masses, slowly migrating across the globe, shape local weather. Air masses, large bodies of air with uniform temperature and humidity, form over specific regions of the Earth and then move across the globe, bringing their characteristics with them. These air masses move slowly, traveling at a pace determined by the larger atmospheric pressure systems and Earth's rotation. As these air masses migrate, they influence the weather in subtle, gradual ways. For instance, when a warm, moist air mass moves into a cooler region, it can cause precipitation, creating the rainy weather often seen in the spring and summer months. Similarly, when cold, dry air masses move into warmer areas, they can lead to dry conditions, often associated with winter. The movement of air masses is not abrupt, but part of a slow, continuous shift in the atmosphere. Over time, these shifts create the local weather patterns we experience day to day. The steady movement of air masses reflects the quiet, unhurried rhythm of the Earth's atmosphere, always changing, but in its own time. Following a predictable pattern that shapes our climate, hurricanes form slowly, as if nature is gathering its strength. Hurricanes, or tropical cyclones, are among the most powerful weather systems on Earth. However, their formation is a slow process that begins with the gathering of warm, moist air over the ocean. This air rises and cools, creating low-pressure systems that begin to swirl. As the system grows, the winds increase and the storm gradually strengthens. The development of a hurricane can take several days, even weeks. The system builds slowly, gathering strength as the warm ocean waters continue to fuel it. Once the storm reaches its peak strength, it moves across the ocean, eventually making landfall with devastating winds and heavy rainfall. The slow, building process of a hurricane reflects the immense patience of nature. The storm does not form overnight. It takes time to accumulate the energy needed to become the powerful system we recognize. Hurricanes are a reminder that great forces in nature move slowly, gathering strength over time, before releasing their energy in dramatic but predictable ways. The role of evaporation in weather is gradual, yet significant. Evaporation is a process that occurs slowly but plays a crucial role in the formation of weather systems. Water evaporates from oceans, lakes, and rivers, rising into the atmosphere as water vapor. This water vapor is then carried by winds and, over time, condenses into clouds, contributing to rainfall or snow. Evaporation happens continuously, but its effects are gradual. It takes time for water vapor to rise, travel, and condense into clouds. The release of this moisture into the atmosphere is not instantaneous, but is part of a steady process that shapes the world's weather patterns. This slow, almost imperceptible process is a reminder of the quiet, yet powerful forces at work in the atmosphere. Evaporation is a link in the larger water cycle, moving at its own pace and creating the conditions necessary for rain, snow, and other weather phenomena. Through evaporation, the Earth's weather slowly unfolds. One droplet at a time, precipitation follows a quiet, cyclical rhythm, returning water to the Earth. Precipitation, whether in the form of rain, snow, or hail, is the result of the accumulation of moisture in the atmosphere. Over time, this moisture condenses into droplets or ice crystals that fall back to Earth when they become too heavy to remain in the air. Like many weather processes, precipitation is a gradual, cyclical event. It starts with the evaporation of water, which is then transported by wind and cooled, gradually forming clouds. As the clouds become saturated, the moisture is released in the form of precipitation, returning water to the Earth. Once the precipitation falls, it is absorbed into the ground, or it runs into rivers and lakes, where it eventually evaporates again, starting the cycle over. This cycle, though full of many dramatic changes, moves with a steady, quiet rhythm. It is a reminder that the weather is never stagnant. It is always shifting, moving, and returning to the Earth in cycles that are as slow and constant as time itself. The Earth's biosphere contributes to the regulation of weather patterns. The Earth's biosphere, the layer of life that extends from the soil to the highest clouds, plays an important role in regulating weather patterns. Plants, animals, and microorganisms interact with the atmosphere in ways that influence the movement of air, the composition of gases, and the distribution of moisture. The biosphere, though it might seem passive, is constantly influencing the weather. Trees release moisture into the air through transpiration, which contributes to cloud formation. Plants and soils absorb and release heat in a slow, measured way, helping to moderate the temperature of the Earth's surface. Through these interactions, life on Earth plays a part in the planet's weather system, regulating temperature, humidity, and precipitation like the weather systems themselves. The interactions between life and the atmosphere occur slowly over time, but they are essential to the larger balance of the planet's climate. The biosphere is a reminder that the Earth's weather is not just shaped by the atmosphere, but by every living thing that calls it home. The gentle force of gravity shapes the Earth's weather systems. Gravity is a quiet, unyielding force that exerts its influence on the Earth's weather systems in subtle but powerful ways. It is gravity that pulls water into the oceans, shapes the tides, and keeps the atmosphere close to the Earth's surface. Without gravity, the weather we know would not exist. Gravity also influences the movement of air. As warm air rises, it creates areas of low pressure, while cooler air sinks, creating high-pressure zones. This difference in pressure is what drives winds, pushing air from high-pressure regions to low-pressure areas and causing weather systems to form. The process is slow, steady, and unchanging, like a cosmic clock ticking quietly in the background. Though we may not always notice gravity's influence, it is the constant force that keeps the Earth's weather in motion, pulling everything into a steady, predictable flow. The gentle power of gravity reminds us that even the most invisible forces play a significant role in shaping the world around us. The land absorbs and releases heat, moderating local climates. The land's ability to absorb and release heat is one of the key factors that shapes local weather and climate patterns. During the day, the land warms up as it absorbs sunlight, and at night, it cools down, releasing the heat back into the atmosphere. This slow, rhythmic process affects temperature changes, wind patterns, and moisture levels in a given region. On land, this heat transfer happens gradually, without any sudden shifts. In coastal areas, Where the land is bordered by oceans, this effect is often less dramatic, as the water absorbs and releases heat more slowly than the land does. This difference in heat absorption is one of the reasons coastal areas tend to have milder, more stable climates, while inland areas experience more extreme temperature changes. The gradual warming and cooling of the land remind us that the Earth's climate is shaped by a delicate balance, where slow, consistent processes work together to create the conditions for life. The Earth's atmosphere acts as a protective blanket. The Earth's atmosphere, though thin compared to the size of the planet, is a protective layer that shields us from the harshest elements of space. It filters out harmful radiation from the sun and regulates temperature, preventing extreme heat or cold from overwhelming the surface of the Earth. Without this atmospheric blanket, life as we know it would not be possible. The atmosphere is a constant, quiet force. It is slow-moving, but always present, maintaining its protective role by absorbing and redistributing solar radiation. This process helps maintain the stability of the Earth's weather, ensuring that temperatures remain within a range that supports life. Just as a blanket keeps us warm and safe while we sleep, the atmosphere provides a steady, invisible protection, allowing the planet to maintain a gentle balance. Its slow but essential function reminds us that, while the weather can change rapidly, there are forces at work in the background, quietly keeping everything in check. El Niño and La Niña are part of a larger, slow-moving climate system. El Niño and La Niña are climatic phenomena that result from subtle changes in the ocean surface temperatures in the tropical Pacific. These changes, while they may seem sudden when they occur, are part of a larger cycle that unfolds slowly over years. During an El Niño event, the ocean surface warms, while during a La Niña event, it cools. These shifts influence weather patterns around the world, from rainfall in the Americas to droughts in Australia. The process that causes El Niño and La Niña to occur is gradual and complex, but their effects on the climate can be dramatic. The events themselves do not form quickly. Instead, they build up over time, with the ocean slowly absorbing and releasing heat, altering atmospheric circulation patterns in the process. Like other weather systems, El Niño and La Niña are part of a larger, slow-moving process that shapes the Earth's climate over long periods of time. They serve as a reminder that even the most sudden-seeming events in nature are part of cycles that have been unfolding for millennia, moving in rhythm with the Earth's own slow, steady pulse. Ocean evaporation helps regulate the planet's temperature. Ocean evaporation plays a crucial role in regulating the Earth's temperature, and this process unfolds gradually over time. As the sun's heat warms the surface of the oceans, water molecules evaporate into the atmosphere, carrying energy with them. This energy is released as latent heat when the water vapor condenses to form clouds. The exchange of energy through evaporation helps to stabilize global temperatures, preventing extreme heat or cold from taking over. Evaporation is a slow process, one that happens constantly and continuously, whether or not we notice it. It is an ongoing, cyclical event where the oceans release moisture into the atmosphere, and the atmosphere releases heat back to the oceans. This gradual exchange of energy is what keeps the planet's temperature in balance, ensuring that the weather remains within the range needed for life to thrive. In this way, the Earth's climate is shaped by a slow, steady flow of energy, a process that may seem invisible, but is always at work, moderating temperature and shaping weather patterns in subtle, quiet ways. Landforms such as mountains influence rainfall patterns. Mountains, though they may seem permanent and unchanging, have a profound effect on local weather and rainfall patterns. When moist air moves toward a mountain range, it is forced to rise, cooling as it does so. As the air cools, the moisture condenses into clouds and eventually precipitation falls. The side of the mountain facing the prevailing winds is often much wetter, while the opposite side, in the rain shadow, remains dry. The effect of mountains on weather is gradual but significant. Over time, mountain ranges help shape local climates by directing the flow of air and moisture. This process may seem sudden when we witness a storm over a mountain range, but it is the result of slow-moving, ongoing interactions between the atmosphere and the land. Mountains are a reminder that the Earth's weather is shaped not only by the atmosphere, but also by the land itself, with every mountain range and landform contributing to the slow, steady flow of air and moisture that defines our climate. The steady flow of ocean currents regulates the planet's weather systems. Ocean currents are another example of slow-moving systems that have a profound effect on the planet's weather. These currents, both surface and deep water, move at a pace that is often imperceptible to us. Yet, they play a significant role in distributing heat around the globe, helping to regulate global climate patterns. As warm water from the equator moves toward the poles, and cold water from the poles moves toward the equator, the Earth's weather systems are influenced. The Gulf Stream, for example, carries warm water from the tropics to Europe, moderating the climate there. In the same way, cold water currents help to cool regions and maintain a balance in temperature. The slow, rhythmic movement of these ocean currents is a reminder that the climate is a complex system, shaped by many forces. Though we may not see the currents moving beneath the surface, they're steady. Ongoing flow has a powerful impact on the Earth's weather. The Earth's weather system is driven by the interaction between the oceans and the atmosphere. The Earth's weather is not shaped by a single force, but by the ongoing interaction between the oceans and the atmosphere. The oceans absorb vast amounts of heat from the sun, which warms the air above. This interaction sets the stage for the winds that move moisture across the globe and drives the formation of clouds and precipitation. These interactions happen slowly over time. As the sun heats the surface of the oceans, the air above is warmed, causing it to rise. This rising air creates areas of low pressure, and cooler, denser air rushes in to fill the gap, creating winds. The movement of warm and cool air masses helps create the global wind patterns that shape our climate. The oceans, with their vastness and patience, serve as the foundation for the atmosphere, supporting the gradual exchange of heat, moisture, and air that forms the weather. The slow, yet steady flow of energy from the oceans to the atmosphere shapes the Earth's weather systems. Over time, this delicate balance reminds us that the world is a connected whole, where every part, whether ocean or air, plays its role in maintaining the climate. Snow forms slowly as water vapor crystallizes in cold air. Snow is a beautiful example of nature's slow-moving processes at work. When the air is cold enough, water vapor in the atmosphere undergoes a slow process of crystallization, forming snowflakes. These snowflakes, each one unique, form from tiny water droplets that freeze in the atmosphere and slowly grow larger. As they fall to the ground, the formation of snow is a gradual process, one that requires cold temperatures and the right balance of moisture in the air. Unlike rain, which falls quickly, snow descends slowly, blanketing the world in a peaceful, quiet stillness. The gentle, steady descent of snowflakes is a reminder of the slow-moving forces that create our weather, from the tiny changes in temperature to the formation of ice crystals in the sky. Snow may seem sudden when it arrives, but it is the result of a delicate, gradual process that unfolds quietly in the cold of the atmosphere. The slow formation of snowflakes is a reminder of nature's ability to create beauty from the simplest elements. At a pace that is steady and unhurried, the process of cloud formation is slow. As moisture condenses in the atmosphere, clouds form from the slow process of condensation, where moisture in the atmosphere condenses around tiny particles of dust or smoke. This process begins when warm air rises, carrying moisture with it. As the air cools, the moisture begins to condense into droplets, which cluster together to form clouds. Cloud formation happens gradually, with each droplet of water joining others to form larger clusters. As these clouds build up, they can grow into towering structures or form gentle, wispy layers that drift slowly across the sky. The process of cloud formation is a reminder that nature works at its own pace, forming something beautiful and complex from simple elements. The slow movement of clouds across the sky reflects the unhurried flow of time. Clouds don't form instantly, nor do they disappear quickly. They are part of a larger, ongoing cycle of evaporation, condensation, and precipitation. Unfolding slowly over time, the moon's gravity creates ocean tides, moving water in a slow, rhythmic pattern. The moon's gravitational pull has a profound effect on the Earth's oceans, causing the tides to rise and fall in a steady, rhythmic pattern. As the moon orbits the Earth, its gravity pulls on the oceans, causing the water to bulge out on the side closest to the moon. This creates a high tide. On the opposite side of the Earth, a second high tide occurs due to the centrifugal force created by the Earth's rotation. This process of tidal movement is gradual and constant. The tides rise and fall over the course of about 12 hours, moving slowly in a predictable rhythm. While the tides themselves can seem sudden or dramatic, the forces at play, gravity, rotation, and the moon's orbit are steady and consistent, creating a natural ebb and flow that has been happening for millions of years. The slow, rhythmic rise and fall of the tides is a reminder that even the most powerful forces of nature move at their own pace, with a quiet and constant regularity that shapes the Earth's oceans and weather systems. The atmosphere's layers create a steady balance of pressure and temperature. The atmosphere is made up of several layers, each with its own temperature and pressure characteristics. These layers starting with the troposphere, where weather occurs, and extending up to the thermosphere and exosphere work together to create a steady balance of pressure and temperature across the planet. The slow movements of the atmosphere are what help to regulate the weather. Warm air rises, cool air sinks, and pressure systems shift slowly over time, creating the winds that drive weather patterns. The balance between these layers of air is essential for maintaining the stability of the atmosphere and the steady progression of weather systems. This layered structure of the atmosphere is a reminder of the slow, constant movements that occur above us, regulating temperature, pressure, and weather. Each layer, though invisible to the naked eye, plays its part in creating the conditions necessary for life and weather to unfold in a steady rhythm. The sun's heat is absorbed differently by land and water. Land and water absorb and release heat at different rates, and this difference plays a crucial role in shaping the weather. Land heats up more quickly than water, and it also cools more quickly. Water, on the other hand, takes longer to absorb heat and to release it. This difference in heat absorption is responsible for the formation of wind patterns. As warm air rises over the land and cooler air moves in to replace it, this process is gradual, with the Earth's land and oceans exchanging heat in a steady rhythm that influences weather patterns across the globe. The slow absorption and release of heat by the Earth's surface create the conditions for the winds, currents, and atmospheric shifts that drive weather systems. Just as land and water interact in this slow exchange of heat, so too does the Earth's atmosphere move in a steady, gradual way, shaping the weather over time. These subtle, continuous processes remind us that the world around us is always changing, but at a pace that allows us to feel the rhythm of the Earth's movement. Weather is a result of the Earth's interactions with the cosmos. The Earth's weather is not solely a result of atmospheric conditions, it is also influenced by the planet's position in the cosmos. The Earth's rotation, its orbit around the sun, and the pull of the moon all affect the weather in gradual but profound ways. These cosmic forces interact with the atmosphere, influencing everything from day and night cycles to seasonal changes, ocean currents, and even the formation of storms. While these cosmic forces are constant and unchanging, their effects on the Earth's weather are slow and gradual. The Earth's movements through space create cycles of heating and cooling, of light and darkness, that shape the weather over time. The quiet, unhurried movement of the Earth through space is a reminder that the weather we experience is part of a larger, ongoing dance of forces, all of which are interconnected and working together to create the world we know. The Earth's temperature is regulated by a balance between energy absorption and reflection. The Earth's surface is constantly absorbing energy from the sun, but it also reflects some of that energy back into space. This balance between energy absorption and reflection is crucial in maintaining the planet's temperature. Darker surfaces, such as oceans and forests, absorb more heat, while lighter surfaces, like ice caps and snow, reflect more sunlight. This subtle interplay between absorption and reflection regulates the Earth's climate, creating conditions conducive to life. The process of energy absorption and reflection is slow and steady. It does not happen suddenly, but is part of a constant, ongoing rhythm that moderates the Earth's temperature. Changes in this balance, such as the melting of ice caps or deforestation, can gradually affect the planet's climate, leading to longer-term shifts in weather patterns. This quiet balance serves as a reminder of the delicate nature of Earth's climate system, how even the smallest shifts in energy can have lasting effects on the weather and the world around us. The Earth's rotation affects the weather patterns through the Coriolis effect. The rotation of the Earth is a subtle but powerful force that influences weather patterns through the Coriolis effect. This effect causes moving air and water to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere, which affects wind and ocean currents. As a result, weather systems like cyclones and trade winds move in curved paths, not straight lines. The Coriolis effect is a slow-moving force that subtly shapes weather patterns over time. It's not something we see directly, but its influence is felt every day. The constant, steady rotation of the Earth drives this effect, creating wind patterns and ocean currents that influence weather around the world. This quiet, steady movement reminds us that even the most invisible forces of nature have profound effects on the weather. The Coriolis effect is one of the many invisible threads that connect the movements of the Earth's atmosphere, creating the conditions for weather to unfold over time. The Earth's oceans play a crucial role in the water cycle. The Earth's oceans are at the heart of the water cycle, as they are the largest source of water that fuels evaporation. Oceans provide the moisture that rises into the atmosphere, eventually forming clouds, and then falling as precipitation, which replenishes fresh water sources on land. This slow and steady process is essential for maintaining the Earth's water systems. The movement of water from the oceans to the atmosphere and back again is a constant, ongoing cycle. Over time, the oceans absorb heat and moisture from the atmosphere, helping to regulate temperatures and weather patterns. The evaporation and precipitation process, though gradual, shapes everything from rainfall to the growth of vegetation. The ocean's role in the water cycle is a reminder of the Earth's interconnected systems. These processes unfold slowly, but they are always working in the background, ensuring the steady flow of water that sustains life. Atmospheric pressure systems slowly shape local weather. Atmospheric pressure systems areas of high and low pressure are key drivers of local weather. High pressure systems are associated with clear skies and dry conditions, while low pressure systems bring cloud cover, rain, or snow. These systems move across the Earth slowly, guided by wind patterns and influenced by temperature and the rotation of the Earth. High and low pressure systems develop gradually over time as air masses move and interact. The shift between these systems can take hours or days, as air pressure rises and falls in response to changes in temperature and moisture. The slow and steady movement of pressure systems across the globe helps regulate weather patterns, guiding everything from rainfall to temperature shifts. These pressure systems are a reminder of how the atmosphere works in subtle ways, shaping our daily weather. Though these systems seem to change suddenly, their movement is a gradual process that unfolds over time, marking the steady rhythm of the Earth's climate. The composition of the atmosphere affects the Earth's climate. The Earth's atmosphere is made up of a mixture of gases that influences the planet's climate. Carbon dioxide, methane, and water vapor are greenhouse gases that trap heat in the atmosphere, keeping the Earth warm enough to support life. This process, known as the greenhouse effect, is gradual and essential to maintaining stable temperatures on the planet. The concentration of greenhouse gases in the atmosphere can change slowly over time due to both natural processes and human activity. For instance, volcanic eruptions can release large amounts of carbon dioxide, and the burning of fossil fuels can increase methane levels. These gradual shifts in the composition of the atmosphere can influence long-term climate changes, including shifts in weather patterns and temperature. The atmosphere's composition is a quiet but powerful factor in regulating the Earth's climate. The gradual buildup or reduction of greenhouse gases shapes the planet's weather over time, reminding us that even the invisible gases in the air play a significant role in maintaining balance on Earth. The slow shifting of tectonic plates affects the climate over millions of years. The movement of tectonic plates beneath the Earth's surface is a slow and powerful force that shapes the planet's landscape and, over millions of years, can influence the climate. As plates shift, they create mountain ranges, volcanoes, and ocean basins, all of which affect the flow of ocean currents and atmospheric conditions. Over vast timescales, tectonic movements have contributed to the gradual warming or cooling of the planet. Though tectonic shifts happen over millions of years, their effects on the climate are profound. The creation of mountain ranges can alter wind patterns, while volcanic activity can release gases that affect global temperatures. These gradual shifts remind us of the immense forces that shape the planet. Even though they move at a pace beyond human comprehension, the slow, steady movement of tectonic plates is part of the ongoing cycle of the Earth's evolution. Over time, these movements create the conditions that allow weather systems to unfold in new ways. With long-term impacts on the climate. The Earth's magnetosphere shields us from solar radiation. The Earth's magnetosphere, an invisible field that surrounds the planet, protects us from the harmful effects of solar radiation. This magnetic field is generated by the movement of molten iron in the Earth's outer core, and it deflects charged particles from the sun, preventing them from reaching the surface. The magnetosphere operates on a gradual, steady basis, consistently shielding the Earth from solar wind. While solar storms and flare-ups can affect the magnetic field, the overall protection it provides is constant and unyielding. The magnetosphere's role in safeguarding life on Earth is a reminder that there are many forces, invisible yet essential, that regulate the planet's systems. Though it may seem quiet and passive, the magnetosphere is an active protector of life, allowing the Earth's weather systems to unfold without the constant threat of harmful radiation. Its slow, steady influence is one of the many unseen forces that help sustain life on Earth. Weather patterns evolve slowly over time as the Earth's systems change. The weather we experience today is the result of countless, slow-moving processes that have been unfolding for millions of years. From the rotation of the Earth to the interaction of the ocean and atmosphere, weather is not just a random series of events, but a reflection of the Earth's complex, interconnected systems. Over time, the Earth's climate and weather patterns change. The warming of the atmosphere, shifting ocean currents, and changing atmospheric composition all contribute to gradual shifts in weather. These slow-moving changes remind us that the world is always evolving, and that each shift in the weather is part of a larger, ongoing process that has been in motion for eons. As we observe the slow evolution of weather patterns, we can appreciate the delicate balance of forces at work. Weather is not just a passing phenomenon. It is a part of the ongoing story of the Earth, unfolding steadily over time. The Earth's natural cycles regulate the climate over time. The Earth's climate is regulated by a variety of natural cycles, such as the carbon cycle, the water cycle, and the nitrogen cycle. These cycles are slow, steady, and ongoing, with each one playing a role in shaping the climate. The carbon cycle, for example, involves the exchange of carbon between the atmosphere, oceans, soil, and living organisms, helping to maintain the balance of greenhouse gases in the atmosphere. These natural cycles work in harmony, slowly and steadily maintaining the Earth's climate over long periods of time. While these cycles may fluctuate, they are always at work, ensuring that the planet remains in a state of balance. This balance is essential for supporting life, and it is maintained through slow, continuous processes that have been unfolding for billions of years. The natural cycles that regulate the climate are a reminder that the weather is part of a much larger, ongoing system. The Earth's climate is not a fixed, unchanging entity, but one that is constantly evolving, driven by slow-moving, interconnected processes that sustain life. The Earth's tilt affects the intensity of sunlight. The tilt of the Earth's axis is responsible for the intensity of sunlight that reaches different parts of the planet throughout the year. This tilt, which is approximately 23.5 degrees, causes the angle at which sunlight strikes the Earth to change as the planet orbits the sun. During summer, the hemisphere tilted toward the sun receives more direct sunlight, resulting in longer days and warmer temperatures. Conversely, during winter, the opposite hemisphere is tilted away from the sun, leading to shorter days and cooler temperatures. This gradual shift in the intensity of sunlight is a defining feature of the seasons, influencing not only temperature, but also the length of day and night. The Earth's tilt is a slow, steady force that shapes the rhythms of nature, guiding the cycle of growth, decay, and renewal that defines our world. The tilt reminds us that the weather and climate are not static. They are part of a larger, slow-moving process that unfolds over time, creating the conditions for life to thrive. Each seasonal change is a quiet reminder that the Earth is in constant motion, moving through time in an unhurried but steady way. The relationship between Earth's atmosphere and oceans is vital for weather. The interaction between the Earth's atmosphere and oceans plays a crucial role in shaping weather patterns. The oceans absorb vast amounts of heat from the sun, storing energy that is then released into the atmosphere, creating temperature and pressure changes. This interaction drives the formation of winds, clouds, and precipitation, making the oceans a key component in the global weather system. Over time, the ocean's heat influences weather systems by affecting the distribution of moisture and energy in the atmosphere. For example, the warming of ocean waters during El Niño events can lead to changes in rainfall patterns and increased storm activity. This process happens gradually, with the oceans releasing and absorbing heat in a constant, steady rhythm. The connection between the oceans and the atmosphere reminds us that weather is not just an atmospheric phenomenon, it is the result of a delicate, continuous interaction between the Earth's air and water systems. The oceans move slowly, releasing energy over time, while the atmosphere responds, creating the weather patterns we experience. The process of water evaporation and condensation shapes our climate. Evaporation and condensation are key processes that drive the water cycle and shape the Earth's climate. When water evaporates from the surface of the oceans, lakes, and rivers, it rises into the atmosphere as water vapor. This vapor then cools and condenses into clouds, which eventually release precipitation in the form of rain, snow, or hail. This cycle of evaporation, condensation, and precipitation is essential for maintaining the Earth's water supply and regulating temperature. The process of evaporation and condensation is gradual. Water vapor rises slowly, and condensation takes time as the air cools. Precipitation then occurs as clouds grow heavy with moisture, releasing water back to the Earth. This slow process ensures that the weather is always in flux, moving between states of calm and activity, creating the conditions for life. These processes unfold in a steady, rhythmic cycle that has been occurring for billions of years. They are a reminder of how the Earth's systems are interconnected, with each cycle playing a role in maintaining the balance of the planet's climate and weather. Ocean currents move in slow, steady patterns, shaping regional climates. Ocean currents, both surface and deep water currents, play a crucial role in regulating regional climates. These currents are driven by the wind, the rotation of the Earth, and differences in temperature and salinity between different parts of the ocean. The movement of these currents is slow, but their impact on weather patterns can be significant, as they help to distribute heat and moisture across the globe. For example, the Gulf Stream, a warm ocean current in the North Atlantic, helps to moderate temperatures in Western Europe, keeping the region warmer than other areas at similar latitudes. Conversely, cold ocean currents, such as the Humboldt Current off the coast of South America, help to cool the surrounding regions. The movement of ocean currents is gradual, occurring over days, months, or even years. This slow process shapes the climate of entire regions, providing a steady source of heat or cooling that influences weather patterns. Ocean currents are a reminder that the Earth's weather systems are not instantaneous. They are part of larger, ongoing cycles that unfold over time, influencing the climate in subtle but profound ways. Volcanic eruptions can affect the weather in slow, lasting ways. Volcanic eruptions release gases and ash into the atmosphere, which can have lasting effects on the Earth's weather. When a large eruption occurs, it can send particles of ash and sulfur dioxide high into the atmosphere, where they can block sunlight and cause temperatures to drop. This effect, known as volcanic winter, is a slow process that unfolds over months or even years. The cooling effects of volcanic eruptions are not immediate, or rather build up gradually as particles and gases accumulate in the atmosphere. This slow process can lead to significant changes in regional and global weather patterns, including cooler temperatures, altered precipitation, and changes in wind patterns. Volcanic eruptions remind us that the Earth's weather systems are influenced by both gradual and sudden events, and that even dramatic occurrences can have long-lasting effects. While the eruption itself may be brief, the changes in weather caused by the eruption can unfold slowly, shaping the climate for years to come. The Earth's atmospheric layers work together to regulate temperature. The Earth's atmosphere is composed of several layers, each of which plays a role in regulating temperature and weather. The troposphere, the layer closest to the Earth's surface, is where weather occurs. It is in this layer that heat from the Earth's surface rises, causing it to move and form weather systems. Above the troposphere lies the stratosphere, which contains the ozone layer, which helps to absorb and block harmful ultraviolet radiation from the sun. These layers of the atmosphere work together to create a stable environment for life on Earth. The slow process of heat transfer from the surface to the atmosphere, combined with the protective role of the ozone layer, helps to maintain a balance that keeps the Earth's temperatures within a range suitable for life. The Earth's atmospheric layers act in unison, creating a system of regulation that unfolds slowly over time. While the weather may change rapidly in the short term, the layers of the atmosphere ensure that the planet remains in balance, providing a steady foundation for life. Sunlight provides the energy that drives all weather patterns. The sun is the ultimate source of energy for the Earth's weather systems. Sunlight heats the Earth's surface, causing it to rise, creating pressure systems, and driving the movement of winds. As the sun's energy is absorbed by the land and oceans, it is released back into the atmosphere, helping to maintain the planet's temperature and regulating weather patterns. The process of energy absorption and release occurs gradually, with the sun providing a constant source of heat. The slow movement of solar energy through the atmosphere shapes everything, from the formation of clouds to the intensity of storms. Sunlight is a reminder that weather patterns are not random, but are driven by the steady, unchanging force of the sun. The Earth's wind patterns are influenced by the planet's rotation. The Earth's rotation plays a crucial role in shaping wind patterns across the planet. As the Earth spins on its axis, it causes the winds to shift direction in a process known as the Coriolis effect. In the northern hemisphere, winds are deflected to the right, and in the southern hemisphere, they are deflected to the left. This creates a pattern of circulating winds that shape the movement of air, moisture, and weather systems. These winds do not move suddenly. Instead, they follow a slow, steady path determined by the Earth's rotation and the pressure systems at play. The movement of winds, like the Earth itself, occurs gradually, with air masses shifting and swirling in response to the changes in pressure and temperature around the globe. These slow-moving winds, over time, influence weather systems by pushing warm and cool air to different regions, creating patterns of precipitation, storms, and temperature. The constant movement of winds, influenced by the Earth's rotation, is a reminder that the planet's atmosphere is in constant motion. The slow, steady circulation of air creates the weather systems we experience, shaping the climate in a predictable, yet dynamic way. Clouds form and move slowly, carrying moisture across vast distances. Clouds are a natural result of the slow process of condensation. As warm, moist air rises into the atmosphere, it cools and the moisture within it condenses into tiny water droplets, forming clouds. These clouds move slowly across the sky, carried by wind patterns, and they hold moisture that will eventually fall as precipitation. The movement of clouds, though they may appear to drift quickly across the sky, happens gradually as they respond to changing air pressures and temperatures. Clouds can travel thousands of miles, influenced by the wind and Earth's rotation. They can form high in the atmosphere, gathering moisture as they move, or they can form closer to the surface, creating fog or mist. The process of cloud formation is a gentle, slow-moving cycle, unfolding over hours or days as moisture rises, condenses, and is eventually released back to Earth. Clouds are a reminder that the weather is a slow, continuous cycle, one that unfolds gradually as moisture is carried across the sky. They remind us that nature's processes move at their own pace, shaping the world in subtle but meaningful ways. Air pressure systems move slowly, influencing weather patterns over time. Air pressure systems areas of high and low pressure play a significant role in shaping weather patterns. High pressure systems are associated with clear skies and calm conditions, while low pressure systems often bring clouds, rain, or storms. These systems move slowly across the globe, driven by changes in temperature, moisture, and the Earth's rotation. The gradual movement of these systems can take hours, days, or even weeks, depending on their size and the atmospheric conditions at play. As air moves from areas of high pressure to areas of low pressure, it carries moisture with it, forming clouds and creating precipitation. This slow process of shifting pressure systems shapes the daily weather we experience, but it is also part of larger, more gradual shifts in the climate. The slow movement of air pressure systems reminds us that the weather is a dynamic, ever-changing system, shaped by forces that move at their own pace. These systems do not change instantly, but shift gradually, influencing the weather over time. The atmosphere's ability to trap heat is critical for regulating Earth's temperature. The Earth's atmosphere is capable of trapping heat through the greenhouse effect, a process that is gradual but vital for maintaining life on Earth. As sunlight reaches the Earth's surface, it warms the land, oceans, and atmosphere. Some of this heat is absorbed, but much of it is reflected back towards space. Greenhouse gases in the atmosphere, such as carbon dioxide, water vapor, and methane, trap some of this heat, preventing it from escaping into space. This trapping of heat is a slow process that occurs gradually over time, helping to maintain the Earth's temperature within a range suitable for life. Without the greenhouse effect, the Earth's surface would be much colder, and many of the weather systems we experience would not be possible. The atmosphere's ability to retain heat is essential for sustaining life, and it works continuously, ensuring that the Earth remains within a habitable climate range. The slow, steady process of heat retention in the atmosphere is a reminder that the climate is finely tuned, with each element of the atmosphere working together to create the conditions necessary for life. Changes in land cover influence regional weather patterns over time. Land cover, such as forests, deserts, and urban areas, can have a significant impact on local weather patterns. Forests, for example, release moisture into the air through transpiration, which can lead to cloud formation and precipitation. Urban areas, with their dense buildings and roads, can absorb more heat, creating heat islands that raise local temperatures. These changes in land cover happen gradually, with human activity or natural shifts in vegetation altering the balance over time. As land cover changes, the local weather patterns can shift as well. The loss of forests, for example, can reduce the amount of moisture released into the air, leading to drier conditions. Conversely, the expansion of urban areas can create localized warming, influencing temperature and precipitation patterns. These changes occur slowly, over years or even decades, but their impact on regional weather is lasting. The slow process of land cover change is a reminder that human actions and natural processes are intertwined with the weather. The gradual alteration of the landscape shapes the local and global climate in ways that unfold over time. Ocean surface temperatures affect the development of storms. Ocean surface temperatures play a key role in the development and intensity of storms. Warm ocean waters provide the energy needed to fuel hurricanes, typhoons, and cyclones. As the sun heats the surface of the oceans, the warm water evaporates, rising into the atmosphere as moist air. This warm, moist air rises and cools, forming clouds and storms. These storms develop gradually, with the warm waters of the ocean feeding energy into the system. Over days or weeks, a low-pressure system can grow into a powerful storm. Driven by the energy from the ocean, the process is slow and steady, with the ocean surface temperature playing a critical role in determining the strength and path of the storm. The development of storms reminds us that the weather is driven by gradual processes, shaped by the constant interaction between land, air, and water. These forces, while dramatic when they occur, build slowly and steadily over time. The Earth's land masses create distinct weather patterns. Land masses, with their varied topographies and climates, play a significant role in shaping the weather. Mountains, deserts, and forests all influence local weather conditions by affecting temperature, precipitation, and wind patterns. For example, mountain ranges act as barriers to airflow, causing air to rise and cool, leading to precipitation on one side while creating dry conditions on the other. In what is known as the rain shadow effect, the slow movement of air across these land masses, influenced by the shape and size of the land, creates distinct weather patterns that define the climate of each region. These patterns develop gradually over time as air masses move and interact with the land, creating cycles of wet and dry, hot and cold. Over centuries, the land masses have shaped the climate in these regions, providing the foundation for the ecosystems that thrive there. Land masses are a reminder that weather is not just a product of atmospheric conditions, but also a result of the landscape. The Earth's surface features play a slow, steady role in shaping the weather patterns that define different regions. The slow movement of tectonic plates alters the Earth's weather systems. Tectonic plates, the massive slabs of rock that make up the Earth's crust, are constantly moving, albeit at an incredibly slow rate. These movements can shape the Earth's surface, creating mountain ranges, valleys, and ocean basins. Over millions of years, the movement of these plates can affect the planet's weather systems by altering the distribution of land and sea, which in turn impacts ocean currents, wind patterns, and atmospheric circulation. As tectonic plates shift, they can create barriers that influence weather patterns, such as mountains that block the movement of air and moisture. Similarly, the formation of new ocean basins or the alteration of ocean currents can lead to long-term changes in regional climates. These gradual shifts remind us that the weather is not static, but shaped by ongoing geological processes that span millions of years. The slow movement of tectonic plates shows us that the Earth's weather systems are influenced by forces that take time to unfold. They are part of a larger, ever-changing system of natural processes that continue to evolve over vast periods. Solar radiation influences temperature patterns over time. Solar radiation is the primary source of energy that drives the Earth's weather patterns. The amount of solar radiation that reaches the Earth's surface varies depending on factors, such as the time of year, the Earth's tilt, and its position in the orbit around the Sun. While the Sun's radiation is a constant force, it fluctuates in intensity throughout the year, causing temperature patterns to shift gradually throughout the seasons. Solar radiation becomes more direct during the summer and less direct during the winter, resulting in changes in temperature and weather patterns. This slow variation in solar energy influences everything from daily temperature fluctuations to long-term climate cycles. The gradual shifts in solar radiation remind us that the weather is driven by forces that are constant, yet change over time, influencing the rhythms of the natural world. As solar radiation varies, it drives the Earth's weather system in predictable ways, shaping the climate and ensuring that the planet remains within a habitable range of temperatures. The process unfolds over time, creating a slow but steady flow of energy that fuels the cycles of weather and climate. Human activity influences weather patterns over time. While natural forces have always shaped the Earth's weather, human activity has increasingly become a significant factor in influencing weather patterns. Activities such as deforestation, urbanization, and the burning of fossil fuels release greenhouse gases into the atmosphere, contributing to global warming. This gradual increase in global temperatures is altering weather patterns, including the frequency and intensity of storms, droughts, and rainfall. Human impact on the weather is a slow but undeniable force. As the Earth's temperature rises, we are seeing changes in precipitation patterns, melting polar ice, and more extreme weather events. These changes are not instantaneous, but are part of a longer-term trend that is altering the planet's climate. It's a reminder that our actions, though seemingly small on a daily basis, can have lasting effects on the Earth's weather systems as we look to the future. It is clear that human activity is reshaping the weather. The slow buildup of carbon dioxide and other greenhouse gases in the atmosphere is contributing to changes in the climate that will unfold over decades and centuries, altering the natural rhythms of weather and climate. Temperature variations between the land and oceans drive the global wind patterns. The temperature differences between land and ocean surfaces play a key role in driving global wind patterns. Oceans, with their high heat capacity, warm and cool more slowly than land, creating temperature differences between coastal regions and inland areas. This variation in temperature creates pressure systems that drive wind, moving air from areas of high pressure to low pressure. The process is gradual and constant. As the land heats up faster than the ocean during the day and cools more quickly at night, winds shift between land and sea, creating land breezes and sea breezes. Over larger scales, these temperature differences contribute to global wind patterns, such as the trade winds, westerlies, and polar easterlies, which influence weather systems around the globe. These wind patterns move slowly, shaping the weather over time. These interactions between land and ocean temperatures remind us that the weather is part of a larger, interconnected system. The movement of air is not chaotic, but follows a steady, predictable rhythm, influenced by the planet's surface features and the slow exchange of heat. The steady movement of ocean water helps distribute heat across the planet. Ocean currents, driven by wind, the Earth's rotation, and the distribution of heat, play a critical role in regulating global temperatures. Warm water from the equator flows toward the poles, while cold water from the poles moves toward the equator, creating a continuous circulation of heat. This process helps moderate global temperatures, preventing extreme heat at the equator and extreme cold at the poles. Ocean currents move slowly but consistently, creating a system of heat distribution that stabilizes the climate. As warm water moves across the surface of the ocean, it transfers heat to the atmosphere, influencing weather patterns around the globe. Similarly, cold water currents help to cool regions, influencing the development of weather systems and shaping regional climates. This slow movement of ocean water is an essential part of the planet's climate system, helping to maintain balance by distributing heat over vast distances. The steady, ongoing circulation of ocean currents reminds us that even the most powerful forces of nature work gradually, moving with a constant rhythm that shapes the weather. The Earth's natural greenhouse effect maintains life-friendly temperatures. The Earth's natural greenhouse effect is essential for maintaining temperatures that support life. Without this process, the Earth's average temperature would be far colder, making it difficult for plants and animals to survive. The atmosphere, which contains greenhouse gases such as carbon dioxide, water vapor, and methane, traps heat from the sun, keeping the planet warm enough for life to thrive. This greenhouse effect works slowly, ensuring that the temperature of the Earth remains within a range suitable for life. While the sun's energy is absorbed by the Earth's surface, some of it is radiated back into space. The greenhouse gases in the atmosphere trap some of this energy, creating a layer of warmth around the planet. This gradual process helps maintain a stable climate over time. The natural greenhouse effect is a reminder that the Earth's weather systems are finely tuned. While changes in greenhouse gas levels can influence the climate, the steady process of heat retention is what keeps the planet hospitable for life, allowing weather patterns to unfold in a way that supports ecosystems across the globe. The Earth's ice caps play a crucial role in reflecting sunlight and regulating temperature. The Earth's ice caps, located at the poles, play a crucial role in regulating global temperatures by reflecting sunlight. Ice and snow have a high albedo, meaning they reflect a large portion of the sun's energy back into space. This helps to prevent the Earth from absorbing too much heat and contributes to the planet's overall cooling process. The process of sunlight reflection by the ice caps is gradual, but over time, it has a significant effect on the planet's climate. As the ice caps reflect sunlight, they help maintain cooler temperatures at the poles and regulate the temperature of the Earth as a whole. This slow and steady process of heat regulation is vital for maintaining the balance of the climate and preventing extreme global temperatures. However, as the ice caps melt due to global warming, the albedo effect decreases, and more sunlight is absorbed by the Earth's surface, leading to further warming. This gradual change reminds us of the interconnectedness of the Earth's systems and the slow but powerful role the ice caps play in regulating temperature and shaping the weather. Seasonal changes in sunlight cause gradual shifts in weather patterns. The Earth's tilt and its orbit around the sun cause gradual shifts in weather patterns throughout the year. As the Earth moves around the sun, different parts of the planet receive varying amounts of sunlight, leading to the changing of the seasons. These changes are not instantaneous but happen gradually over time, influencing temperature, precipitation, and atmospheric conditions. Seasonal shifts in sunlight also affect the length of day and night, with longer days during the summer months and shorter days in winter. This gradual change in sunlight causes seasonal weather patterns, from the warmth of summer to the coolness of winter. These seasonal shifts are predictable, unfolding steadily over time as the Earth moves through its orbit. The changing of the seasons is a natural, slow-moving process that reflects the rhythms of the Earth's journey around the sun. Each season brings its own unique weather patterns, shaped by the gradual change in sunlight, temperature, and atmospheric conditions. The sun's energy drives atmospheric convection. The energy from the sun is the primary driver of atmospheric convection, which is the process by which warm air rises and cooler air sinks. As the Earth absorbs sunlight, the surface heats up, causing the air above it to warm. This warm air becomes less dense and rises, while the cooler air from higher altitudes moves downward to take its place. This slow process is part of the larger system of air circulation that drives the weather. Convection is responsible for creating wind, which moves moisture and heat across the planet. The movement of warm and cold air masses helps regulate temperature and precipitation, shaping local weather patterns. This slow, continuous process is at the heart of many weather systems, from gentle breezes to intense thunderstorms. Convection is a reminder that the atmosphere is in constant motion. The steady rise and fall of warm and cold air is a fundamental aspect of how the Earth's weather operates, moving moisture and heat around the globe in a way that shapes the climate. The Earth's oceans are crucial in storing and releasing heat. The oceans play a critical role in storing and releasing heat, acting as the planet's heat reservoir. Water has a high heat capacity, meaning it can absorb and hold large amounts of heat without dramatically increasing in temperature. This slow process helps to stabilize the Earth's climate by preventing rapid temperature fluctuations. As the sun heats the oceans, the water absorbs this energy, and when the Earth cools at night, the oceans gradually release the stored heat back into the atmosphere. This process, which occurs continuously, is vital for regulating temperatures across the planet. In particular, the oceans help moderate coastal weather, preventing extreme heat and cold. The slow and steady heat exchange between the ocean and atmosphere is a key element in maintaining balance in the Earth's weather systems. It provides a buffering effect against rapid temperature changes, contributing to more stable weather patterns over time. The water cycle is a continuous, slow-moving process. The water cycle, also known as the hydrological cycle, is a continuous process by which water evaporates from the Earth's surface, rises into the atmosphere, condenses in the clouds, and returns to the surface as precipitation. This cycle operates at a gradual pace, moving water through the atmosphere, rivers, lakes, and oceans over time. As the sun heats the surface of the oceans, water evaporates into the atmosphere. When the air cools, the moisture condenses in the clouds, and eventually, this moisture falls back to Earth as rain, snow, or other forms of precipitation. This water then flows into rivers and streams, eventually returning to the oceans, where the cycle begins again. The slow, Steady movement of water through the cycle shapes the planet's weather by regulating moisture levels and temperature. It is a constant reminder that the weather is not just a set of isolated events, but part of an ongoing process that affects the Earth in continuous and gradual ways. The polar regions help to regulate global temperature. The polar regions play a crucial role in regulating the Earth's temperature by reflecting sunlight away from the surface. The ice and snow in these areas have a high albedo, meaning they reflect a significant portion of the sun's energy back into space, helping to cool the planet. This slow process helps maintain temperature balance across the Earth dot as global temperatures rise. However, the ice at the poles melts, decreasing the albedo effect and allowing more sunlight to be absorbed by the Earth's surface. This accelerates warming, further melting the ice and creating a feedback loop. The gradual melting of polar ice is one of the most noticeable indicators of climate change, with profound implications for global weather patterns. The slow, steady role of the polar regions in regulating temperature underscores the delicate balance that governs the Earth's climate. The polar regions, though distant, have an outsized effect on the weather, helping to keep the planet's temperature within a range that supports life. The changing tilt of the Earth's axis causes long-term climate shifts. Over thousands of years, the tilt of the Earth's axis changes slightly in a process known as axial precession. This slow variation in the tilt influences the intensity of the seasons, leading to long-term shifts in climate. When the tilt of the Earth's axis increases, the seasons become more extreme, with warmer summers and colder winters. When the tilt decreases, the climate becomes more temperate, with milder seasonal changes. This gradual shift in the Earth's tilt is part of a larger cycle that influences climate patterns over time. The effects of axial precession are slow, but over the course of millennia, they can lead to significant changes in global temperature and weather patterns, contributing to cycles of ice ages and warmer periods. These gradual changes in the tilt of the Earth's axis remind us that the weather is not only shaped by short-term factors, but is also influenced by long-term cycles that operate on vast time scales. Ocean temperatures affect global weather patterns. Ocean temperatures play a major role in shaping global weather patterns by influencing atmospheric circulation. Warm ocean waters provide energy for weather systems, fueling tropical storms and influencing rainfall patterns. Conversely, cooler ocean temperatures help regulate the global climate by stabilizing air temperatures. Changes in ocean temperatures, such as those caused by El Niño and La Niña, can have widespread effects on weather, including shifts in rainfall, temperature, and storm intensity. These changes occur gradually as the oceans warm or cool over time, but their effects can be dramatic. The gradual heating or cooling of ocean waters alters the flow of air, contributing to long-term changes in regional and global weather patterns. The slow-moving influence of ocean temperatures reminds us that weather is shaped not only by atmospheric conditions, but also by the oceans, which store and release heat, influencing climate and weather across the globe. The movement of the Earth's crust creates mountains and valleys that influence weather patterns. The movement of tectonic plates over millions of years has created the Earth's mountains, valleys, and other landforms that influence weather patterns. Mountains, in particular, affect local weather by blocking the movement of air masses. When moist air rises over mountains, it cools and condenses, leading to precipitation. On the leeward side of the mountain, air descends and warms, creating dry conditions. The slow movement of tectonic plates continues to shape the planet's surface, creating new mountain ranges and valleys that alter wind and moisture patterns. These geological processes have a lasting impact on the climate, influencing weather over thousands of years. The gradual reshaping of the Earth's surface by tectonic forces is a reminder that the planet's weather is shaped by processes that unfold slowly but have significant effects on the long term. Climate. Clouds' role in the weather is gradual and continuous. Clouds play an essential role in regulating temperature and precipitation. As moisture rises into the atmosphere, it condenses into clouds, which can then release their moisture as rain or snow. The formation of clouds is a gradual process shaped by the temperature, moisture, and pressure in the atmosphere. Clouds can affect weather in many ways. They reflect sunlight, helping to cool the Earth's surface during the day, and they trap heat at night, helping to keep temperatures more stable. The gradual formation and movement of clouds influence weather over time, shaping rainfall patterns, storm development, and temperature changes. The continuous role of clouds in the weather cycle shows us that weather is an ongoing process. The slow buildup of moisture, the gradual formation of clouds, and their eventual release as precipitation are all part of a larger, dynamic system that operates on long timescales. Wind patterns distribute heat and moisture across the planet. Wind patterns play a crucial role in distributing heat and moisture across the Earth. As warm air rises and cool air sinks, wind is created, moving from areas of high pressure to low pressure. These wind patterns help regulate temperatures by carrying warm air from the equator toward the poles and cool air from the poles toward the equator. The slow movement of air masses and wind patterns shapes the weather by influencing temperature, precipitation, and humidity levels. Winds can carry moisture from the oceans to the land, bringing rainfall to regions that would otherwise be dry. The movement of winds is gradual and continuous, ensuring that the Earth's climate remains in a state of dynamic equilibrium. Wind patterns, shaped by temperature and pressure differences, are a reminder that the weather is influenced by forces that move slowly but steadily. The constant redistribution of heat and moisture helps maintain the balance of the climate and weather systems over time. Thank you for joining me on this peaceful journey through the world of weather. As we've explored, the forces that shape the weather are vast and gradual, moving steadily through time. From the slow dance of the oceans and winds to the quiet shifts in temperature and pressure, the world of weather is one of continuous, calming motion. Remember, as the Earth continues its slow and steady course, so too does nature's rhythm unfold, ever constant and ever patient. I hope these gentle reflections have helped to calm your mind and bring you a sense of peace. If you found this journey soothing, consider returning whenever you need a moment of relaxation. Sleep well, and let the world continue its quiet, timeless dance while you rest.